Hello friends, in this session we are going to talk about what is the meaning of time displaced and space displaced. Let's begin. Yes, see here, what do we mean by time displaced? Time displaced means you are supposed to sit in one single position. You have to sit in one single position like a lazy man and just observe the variations. What did I say? Let me write. See, sit in one single position like a lazy man. Very important. Example, sleeping on the bed or playing some games on mobile phones, PUBG and all, right? Now, see here. Anyways, sit in one single position like a lazy man and observe. Observe what, sir? Observe variations. If you find some or the other variations by sitting at one particular position like a lazy man, if there are some variations, then those will be called as time displaced. What is that? You will understand gradually. Wait. Now, speaking about space displaced, let's see. Space displaced means in no time. What do you mean by no time? No time means without consuming any time. Let me write. Or without consuming any time. What I have to do, sir, in no time, what are we have to do? We have to move through the air gap and observe the variations. Again. See, in no time means without consuming any time. Without consuming any time, we have to move or travel through the air gap and observe the variations. Travel or move. Yes, this is the meaning of space display. But now, you may ask me, sir, you are saying in no time. In no time, that too without consuming any time. Is it even possible, sir? No, right? So, if I am saying that you have to move through the air gap without consuming any time, which means I am saying that stop time. Stop time means, sir, for example, in this whole board, see here, in this whole board, if, for example, there are few equations written, I am the teacher, there are few equations written, and for instance, this board is moving like this. This board is moving like this again and again. Right? Now, if you want to note down those equations, what will you do? What will you do? Please think. Fast. Yes, you are right. For instance, if this video is, let us say, 0.00 minutes to, let us say, 25 minutes. Right? If the video is from 0.00 minutes to, let us say, 25 minutes, and now you want to note down those equations, what will you do? You will stop the time. Stop the time means, sir, basically pause the video. Yes. So now, if the video is, for example, from 0.00 to, let us say, 25 minutes, so in order to note down the equations, which means you need to observe the variations on the board, right? You need to observe those equations there. So, in order to do that, what will you do? You will pause the video. Basically, what do you mean by pausing the video, stop the video, or we can say stopping the time. For example, you are stopping at, let us say, 7.23, means at 7 minutes 23 seconds you are just pausing the video, which means you are stopping time. Why? Because once you pause at 7.23, you are not going to move ahead. I hope you are getting my point. Once you pause at 7.23, this video will not run. Right. Now, after pausing the video, what will be the next step? The next step will be screenshots. You will take the screenshots, right? See, again, stay calm. The video is, let us say, moving like this, right? Now, what do you want to do? You just simply want to note down everything that is written on the board. For example, space, board or space, right? So, what will you do? You will stop the video, you will stop the time, and then observe the variations on the board, and then note them down in your book. Alright, so that is nothing but space displaced. So in no time, or we can say by stopping the time, if you move throughout the air gap and you observe some variations, then those would be called as space displaced. Right, see here now. Let us take case 1. Let us take example of a transformer, very simple example. Before that, let me tell you, what are the parameters which are always going to be time displaced? Let us talk about them. For example, I have a conductor. For example, this is a conductor. Now, let me inject some current I, right? And let me tell you that this current I is alternating AC. Now, is it time displaced or space displaced? Let us try to analyze. See here, it is AC, which means waveform with respect to time will be going to be like this. See, I know you may tell me, sir, AC means triangular wave also, sawtooth also. Yes, I know. But let me consider sinusoidal, just for simplicity. Now see here, this is the current I flowing like this, right? Now, the moment it is AC, now concentrate here, concentrate. See, this is 0, right? This is 180 degrees, right? See here, what is happening. For example, I am here. Here means what? At time of 0 seconds, for example. At time 0, what is going to happen? There will be no current, right? When time comes here, at 90 degrees, what is going to happen? There is going to be positive current, right? Then again, if time comes here, 0 current. If time comes here, negative maximum current. And if time comes here, it is going to be 0 current, right? Now, yes, focus here. See, for example, what was my criteria? Yes, now you tell me, what were the different conditions which had to be satisfied in order to tell that the particular parameter is time displaced? We know that, we know it. See here, what is that? Sit in one position like a lazy man and just observe the variations, right? Right, now see here. Yes. See, for example, I am sitting here like this. I am sitting on the conductor. What will I see? I am sitting there like a lazy man. I am not at all moving. Remember my words. I am just sitting there like a lazy man, like this. Right? Now, what I am going to do? I am just going to observe the variations. What do we mean by observations, sir? Let us see. Come on, focus. See, at time equal to 0, when time was 0, this was zero current was there. The moment time came here, what happened? This zero current became positive maximum, right? Then afterwards zero, then it became what? Negative maximum. Again zero, positive maximum, zero, negative maximum, zero, positive maximum, zero, negative maximum, right? Now you tell me, just by sitting there and doing time pass, just by sitting there and passing the time, was I able to see the variations of the current? Yes, I was just sitting there and doing time pass, just sitting there in one single position, and I was able to see the variations. Zero, positive maximum current, zero, negative maximum, zero, positive maximum, right? Which means current is time displaced. Now, let me check if it is space displaced as well. Let us check it. What is the definition? See here. Space displaced means what? In no time. Means without consuming any time, you have to move throughout the air gap and check if there are any variations. Right? Now, in no time we cannot travel. Right? In no time we cannot travel. That is the reason. What are we going to do? We are going to stop the time. So let us stop the time. See here. Yeah. Stopping the time means, for example, I started the video examples, right? I started the video at, let us say, 000, and I stopped here. I paused the video here at this instant. What is happening there? In this particular instant, there will be positive maximum current, which means there will be positive maximum current like this in this one. Right? This is going to be the positive maximum current. Now you tell me, what will be the value of current here? 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 You please tell me, what will be the value of current in this whole conductor? Same, right? Right. Means everywhere the value of the current is going to be what? Positive maximum. Again. See, I stopped the time. I stopped my current. I didn't stop the current. What I'm saying is, stopping the current means stopping the time interval. I just stopped here. I just paused the video. Now I know that at this instant, what is going to happen? There is going to be positive current. Right? At this particular instant, there is going to be positive current like this. We already know that. Now, the moment at this instant there is going to be positive current, what am I supposed to do? I am supposed to travel through the conductor. There is no air gap, there is a reason. Now, in this case, we are going to travel through the conductor. The moment I am traveling through the conductor, what is going to happen? Same current will be there everywhere in each and every inch of this conductor. There is going to be same current. There is going to be positive current. Now, for instance, if I again play the video, and now I am stopping it here. At this instant, what is going to happen? Zero current is there. The moment at this instant, zero current is there, which means what? Throughout this conductor, there will be zero current. Now, what am I supposed to do? I am supposed to move through this conductor. I am supposed to move through this conductor because I have stopped time. Step 1, stop time. Step 2, travel through the air gap, or in this case, travel through the conductor. Now, step 1 is done. I stopped here. Step 2 is what? Just move through the conductor and observe if there are any variations. And then I see that here also current is 0, here 0, here 0, here 0, here 0, here 0. Which means current is not space displaced because I was not able to find any variations in space. I hope you have got the point, right? Now, let us take another example. Let us take example of a induced voltage. Let us think of voltage. See, before that, from this we have understood that current is always time displaced. It is not at all space displaced. Let me think of voltage. See here. For example, I have a conductor here like this. And in this conductor, let us say I have induced voltage in this direction. Induced voltage like this. Right? Now see here, very important. I am saying that this induced voltage is AC. Alternating, no problem, right? Now, the moment this induced voltage is AC, can I represent the same in this fashion? Can I represent the same voltage by this same figure? E. Let me call it E. No problem. It is going to be AC. What does that mean? See here. See here. When time is zero, induced EMF is zero. Let us start. See again. Very easy. In order to find whether it is time displaced or not, what am I going to do? I am going to sit on the conductor. Let us sit on the conductor here. Right? I am sitting on the conductor and I am sitting there like a lazy man. I am just observing. Now, what is going to happen? See, I am going to pass the time. Let the time pass. I am a very lazy man. Let the time pass. What will happen? See, the moment here we have zero. The moment time is zero, EMF is zero. The moment time is, let us say, 90 degrees, EMF is going to be positive maximum. Means EMF will be like this only. The moment I am here at, let us say, 180 degrees, after some more time, then EMF is going to be again zero. Then here EMF is going to be negative maximum, which means at this instant, let us say at 270 degrees, my EMF will look like this. Firstly, it was zero, positive maximum, zero, negative maximum. This is what the direction of EMF will be. Which means, now you tell me, just by sitting on the conductor like a lazy man and passing time, what do I observe? Do I observe the change in EMF? Yes, I observe, because I was just sitting there like this. And I was able to observe in this conductor, I was able to observe that yes, at some point of time, EMF was zero. At some point of time, EMF was positive maximum. At some point of time, it was negative maximum as well. Which means, again we can say that voltage is time displaced. Now, we need to check whether the voltage or the induced EMF or the EMF is space displaced or not. Let us see. In order to find space displacement, number one step is what? Stop the time. Right? So, let me stop the time arbitrarily anywhere. For example, you are saying that, sir, stop the time here. We need to understand whether it is space displaced or not. Let us check. In order to find the space displacement, what are we supposed to do? Step 1 is what? Yes. Step 1 is, see here, stop the time. Now, you tell me whether I should stop here, or here. Anywhere I can stop. Let us say, just only and only for you, I am going to stop here. You said no, yes sir, stop here. Okay, I stopped here. The moment I am stopping the video here, what is going to happen? Current will be, or voltage will be here only, right? Voltage is going to be positive maximum. Now see here, the moment here I see that the voltage is positive maximum, which means voltage will be like this, plus and minus. Value of the voltage will be positive maximum as well at the same time. Now, if I am moving throughout the conductor, step 2, flow through the air gap, travel through the air gap. So, let me just move through this conductor. What am I going to observe? I will observe that EMF is not changing. Everywhere the voltage is positive maximum only. Let us say here if I observe, second case, you will say, sir, no, you did cheating, sir. You wanted to stop here. Okay, no problem. Let us stop here. The moment you stop here, you are going to pause the video. The moment you pause the video, or you are going to stop this particular voltage, what are we going to do? We are just going to travel through the conductor. The moment I travel through the conductor, what do I observe? I observe that, see here, I observe that everywhere it is 0. The moment I stop my video here, the moment I stop the voltage here, I stop the voltage at this point, which means voltage is now at negative maximum, which means now the voltage is at negative maximum like this, minus plus, polarity will get changed, right? So now if I travel through the conductor, what am I going to observe? I am going to observe that everywhere there is negative voltage, which means EMF or voltage or induced EMF is also not space displaced. Moral of the story, moral of the story. Come on. See here. See here. What are the conclusions here? See. Conclusion number 1. Conclusion number 1. What is that? Currents and voltages are time displaced and not space displaced. Always. And in bracket we have to write that not at all space displaced. In any condition they are not space displaced. Am I correct on this? Now, let us talk about case 1 and case 2. Let us take transformer. See here. Yes. Now, if you see here, we have already discussed that currents and voltages are time displaced and they are not space displaced. Right? Sure. Now, but then sir, what about flux? For flux also we need to do the same analysis. Now, why flux is important? Why we have to analyze flux? Why are we supposed to analyze in flux domain? Let us see. See here. In the first video, we had talked about something called as linear systems and all, right? Linear system, or let us say linear machine and all, right? Linear machine, for example. In that, I told you that number 1, there was a scientist named Morsted, right? He said that whenever there is going to be electric current, there is going to be magnetic flux. Whenever, see, Oster said that whenever there is going to be electric current, there is going to be magnetic flux. Agreed? Now see here. Second, there was a scientist whose name was Ampere. Now, Ampere said that Ampere actually gave the relation between them. Oster said that whenever there is current, there is going to be corresponding flux set up around it. Fine. But then, what is the relation between them? That was given by Ampere. What was that relation? See. The relation was I is proportional to phi. I is proportional to phi. This was the relation given by Ampere. But then he mentioned that this is only applicable when the system is linear. And for time being, I am going to tell you, linear system means mu r is constant. I am saying this for time being. I am saying this for time being that I is proportional to phi means mu r is constant. How it is constant and all we will see later. Time will come when I will be discussing as to why I proportional to phi means mu r is going to be constant. But now what happens is, if you remember in the different stages of analysis, we discussed about it that in ideal machine we are going to neglect or we are not going to consider non-linearities, which means if I proportional to phi is linear, which means linearity means what? Current I is proportional to phi. Now just imagine a situation if it is not proportional to phi. Then then in that case, what will happen? Let us analyze. See here, very easy. Now see here, very easy. We know that I is proportional to phi. Ampere said this, right? Agreed. He said this only and only for linear system. We know that. We have that in our mind. Now, here there will be the distinction between the transformer which we learn in network theory and the transformer which we are going to learn in machines. There is a discussion. See here. Now, we know that network theory is only and only applicable for linear systems. Only applicable for linear systems. And machine analysis is applicable for non-linear. See here. See, we will discuss how and all it will come. See. Now, we know that E is proportional to d phi by dt. Who said this? Mr. Faraday, right? Now, you tell me if I is proportional to phi, meaning that if I is doubled, flux is doubled. I is halved, flux is halved. So, when we are speaking in terms of proportionality, can I say that E is proportional to di by dt? What I have done here? See, I have just replaced this flux by current, and I was able to replace it because I proportional to phi I have considered. And since I know that networks is applicable only and only for linear systems, so that is the reason I have got this relation. Now see here, E proportional to di by dt, let me write it E. Now we know that if we want to remove this proportionality sign, what are we supposed to do? We are going to replace it by equal to and a constant, and then the same thing will be repeated. Now, let me write it one by one. See, which means E is equal to di by dt. Agreed? No, sir. Why? Because this constant has to be written. What is that constant? This constant is nothing but inductance L. This constant is nothing but inductance L. Now let me tell you one thing. Let us try to do the same thing for machines. Let us see. Sir, we know that E is proportional to d phi by dt. Agreed, sir. Now, can I write E is proportional to di by dt? This is the question. Can I write E proportional to di by dt? The answer is no. Why? Because machines are non-linear. And another thing we need to understand, machines are non-linear means mu r is not going to be constant. Why it is not going to be constant, we will discuss, don't worry, time will come. But for time being, you need to understand that this particular phi cannot be replaced with I. Which means whenever I talk about EMF, I have to analyze in flux domain only. I hope you have understood the point. See here, in case of networks, what we do is proportional to d phi by dt, we know from Faraday. Now, since it is applicable for linear systems, networks is applicable for linear systems, E proportional to di by dt can be written means phi can be replaced by I, and then E is equal to L di by dt. We know that, no problem. Now see here, in the second case, in case of machine analysis, what are we going to do? Since mu r is not constant, it is non-linear. All machines are non-linear. keep that in mind. Why they are non-linear, and we purposefully make them non-linear. Why we make them non-linear, we will discuss. Time will come. For time being, just for time being, you need to understand that E proportional to d phi by dt and E proportional to di by dt means flux and current cannot be replaced. Means flux cannot be replaced by current. Flux cannot be replaced by current. This is wrong. In machines, this is wrong. So E proportional to d phi by dt has to be there. Now see here. Now see here. Come on. See here. Focus. Just imagine. If my machines were linear, then is there any requirement to analyze transformers in machines? If you remember, I had told you that machine analysis means basically analysis of rotating machines only. But we know that transformer is a static device. Transformer is a static machine. But still we are analyzing it in machines. Why? Because transformer is non-linear. If transformer was linear, we would have not analyzed it in machines. There was no need to do that equivalent circuit and do the whole stuff. No need. Right? But transformer is non-linear. Why he is non-linear? Because mu r is not constant. Why it is not constant? Because of iron core. You will understand those things gradually, why we are using iron core and all. You will understand everything, don't worry. But just for time being, keep these things in mind, that machine is non-linear because mu r is not constant. Mu r is not constant because we are using iron core, and we are using iron core because without iron core, machine cannot exist physically. Machine cannot exist physically. Mind my words, without iron, machine cannot exist physically. What is the reason, sir? Time will come. Don't worry, just believe me. Time will come, I will explain you why. Now, yes, coming back to the time. See, E proportional to d phi by dt, right? Which means flux cannot be replaced by current. Agreed? The moment we cannot replace flux by current, we have to analyze machines in flux domain. We have to analyze the whole machine in flux domain. Now, the moment we have to analyze the machine in flux domain, we should know things like MMF, reluctance, flux density, etc. So, we should know that, and that is the reason it is very important for us to understand whether flux or MMF or flux density is time displaced or space displaced. So let us see. We have understood the importance of flux. Now let us understand whether it is time displaced or space displaced. Let us see. Yes. So now starting with case 1, let us take transformer. We will be taking only 2 cases in order to understand whether flux is time displaced or space displaced. That's it. Let us see. For example, transformer is there. Now, see here. This is a transformer, right? Now, for example, I am giving AC supply here. Right? Let me give AC supply here. The moment this voltage is AC, EMF induced is going to be AC and the flux is going to be AC. How this particular flux is also sinusoidal, you have already learnt in transformer. We cannot discuss it here. Now see here. The moment we know that this voltage is sinusoidal, my flux is also going to be sinusoidal. Now see here. Let us observe. See. For example, I am sitting here. This is me, I am sitting here. Right? Now, come on, see here. The moment I am sitting here, what is going to happen? Let us see. The moment I know that this flux is time varying, Why? Because this voltage is time varying, voltage is sinusoidal, that is the reason flux is also going to be sinusoidal. Now, see here, the moment this flux is sinusoidal, what is going to happen? At some instant it is going to be 0, at some instant positive maximum, then 0, negative maximum 0. Right? Now say here, focus, come on. This is my flux, right? Now, in order to find whether flux is time displaced or space displaced, let us take case 1. What do we have to do when we are talking about time displaced? Let us see. When we talk about time displaced, means what? You have to sit here like a lazy man, right? You have to sit here and you just need to observe the variations. You just have to let the time pass and observe the variation. Let us see what happens. I'm sitting here like this, lazy man like this, and I am trying to find the variation. Let us see. Now, the moment I am sitting here, I will see that this flux, this particular flux which is there, what will happen? This flux will be 0. The moment this time comes here, what will happen? First will be maximum. Means it will be like 0, positive max. Then again, flux is going to be 0, then negative max, then again 0. Now see here, I am sitting inside the core or on the core, let us say, and I am going to do time pass like a lazy man, just going to observe the variations. Let us see what do I observe. I know that this particular flux at some time, let us say at time 0, it is going to be 0. At time, let us say this time, it is going to be positive maximum. After some time, it is going to be 0. After some time, it is going to be negative maximum. Means, I am sitting here, what will I observe? I will observe this, that the flux is 0. After some time, it is positive maximum. After some time, it is again 0. After some time, it is negative maximum. After some time, it is again 0. After some time, positive maximum. After some time, 0. After some time, negative maximum. 0, positive max, 0, negative max, 0, positive max. This is how the flux will be. Right? Now, is there variation of flux? Yes. And I was able to find or observe these variations of flux just by sitting at one single position and observing, which means flux is time displaced. Agreed? So, can I write here? What do I understand? Flux is time displaced. See here. Let us think if it is space displaced also. What is step 1 for space displaced? Stop time. Means this is the time. This is time t. So let me just stop time. For example, I played the video here and I stopped here. I stopped here. Right? Now at this instant, this flux is going to be positive maximum like this. 0, positive max, 0, negative max, 0, positive max, 0, negative max, 0, positive max. Now, at this instant, another flux is going to be 0, positive maximum like this, right? Now, the moment is this flux is positive maximum, what I am going to do, I am just going to stop the time. I stop the time, which means flux is positive maximum, and the moment my flux is positive maximum, what am I going to do? I am going to travel through this core. I am going to travel through this core. Now the moment I travel through this core, what do I observe? I observe that flux here is also positive maximum. Here also positive maximum. Here also positive maximum. Here also positive maximum. Everywhere the flux is positive maximum. Again, I stop time here. Flux is going to be positive maximum. Now this flux is like this, positive maximum. Now I traveled through this core and I saw that everywhere the flux is going to be positive maximum. The moment flux is positive maximum everywhere, which means it is not space displaced. Then, right? So, can I say that here flux is not space displaced? Now, student asked me, sir, is it applicable always? Why? Because see here, when I talked about, see, here when I was talking Here, in case of currents and voltages, I said one thing, very important point. What was that? Currents and voltages are time displaced always. This word always is very important. But I did not write this word here. Here if you see, have I written that flux is time displaced always, flux is not space displaced always? No. Why? That is the reason we are going to analyze case 2. Let us see what is there in case 2. See here. Yeah, see here, case 2. Let us take case of a DC generator. Now, let me think of DC generator. See here. We know that there is going to be some stator like this. Right? And the stator will have, let us say, north pole here, south pole here. Right? Inside it, I have some rotor. Inside this, I'll be having some rotor. And this particular rotor will have some conductors like this. Right? Stator will be there. And here rotor will be there. Bullseye. Now see here. What is going to happen? There is going to be north to south flux lines. We know that from the basics of time standard. Let me have this. Am I right? Now, focus here. See. For example, I am sitting in the air gap. Now, I want to find whether this flux is time displaced or not. Let me find it out. See. For example, I am sitting here in the air gap here, like this. Like a lazy man. Right? Now, if you say here, this flux, if you see with respect to time, this flux is constant. Now, why? Because it's permanent magnet. Again. It's a DC generator. Right? This is a permanent magnet. The moment this is a permanent magnet, this flux is going to be constant with respect to time. Which means this flux will be like this, let us say. Which means if you see here, this is time, this is let us say flux, then this flux is going to be constant with respect to time. Why? Because it is permanent magnet. Flux will not change with respect to time. So if I am sitting here doing time pass, above me there is the north pole. Above me is my north pole here like this. I am sitting here doing time pass in the air gap. Now, what will happen? I will experience the same flux. I hope you are understanding this. Come on, one more time. See here. I am sitting in the air gap like this, right? Now, above me is what pole? North pole. Flux lines are like this. Flux lines are coming like this through me, right? Now, I am just sitting here doing time pass. Is there any variations? No. I will not at all observe any variations. Why? Because I am just sitting there inside the north pole. Right? Now, the moment I am sitting below this north pole, what is going to happen? I am not going to experience any variations in the flux because I am sitting in one single place. I am sitting in one single place here like this. North pole is here, south pole is here, flux lines are going like this. No problem. I will not find any variation. Right? Now, in this case, if you see, can I say that flux is not time displaced? Let me write it. No. What about space displaced? Step 1 is what? Stop the time. Okay, I stop the time here. Anywhere if I stop, it is going to be the same thing. Let us say I stopped it here. Now, I am going to flush like this from north to south. Now, I am going to travel through this air gap. Stop the time, travel through the air gap. What do I observe? Let us see. If I am sitting here, I am going to move like this. I am moving like this. What do I observe here? Do I observe any variations? Do I observe any variations? Answer will be, some students will say no, some will say yes. What is the right answer? I am saying that here flux will be positive maximum, here flux will be 0, here flux will be negative maximum, here flux will be again 0. You will say, but sir, how you are saying that flux here is 0? How you are saying that flux here is maximum? Flux here is maximum. How are you saying this? You didn't understand anything. For this, let me teach you something called a space distribution. Let us see. For example, these are my two fingers. For example, it is a scissor, right? It is a scissor. Now, what I am going to do here, let us see. This is a scissor. I am going to cut this here, right? I am just simply going to cut here. I am just simply going to cut here and move it like this. I hope you are getting the point. See, this is a rotor or whole structure of the machine. What I am going to do, I am going to make a cut here with a scissor. This cut, and I am going to open it like this. I am going to open it like this. Now, the moment I open it, how will I see it? Let us see. The moment I open it, I will see it like this. Let me take it. Yes, it is visible. See, now, the moment I start here, right? Now, open it like this. What will happen? I will find North Pole here on the top. Right? I will find the South Pole also somewhere. See, here. Here will be North Pole, here will be South Pole. So, let me have South Pole here. Right? Now, below this, there will be these conductors. Agreed? Below this, here will be the conductors. Now, let me have the conductors here. And let me also draw this particular zero flux. Let me draw these two instances also, this and this one. So this will come here, right? And here again, and then again North Pole will come, repeating the things. Now see here, very important. Now see, this is what? This is going to be the North Pole, this is going to be the South Pole. We know that flux lines are coming out of the North Pole. Flux lines are coming out of the North Pole, so flux lines will be coming like this. And in case of South Pole, they are going to enter the piece, iron piece, I mean stator. So it is going to enter here in case of South. Now see, the moment these flux lines are coming out of the stator like this. Now, the moment these flux lines are out of this like this, let me consider this as, let us say, positive like this. Let us see here. This is the flux, let us see. Now see, very important. See, here if you see, this flux is going to be constant. The way this structure is, the same way this structure is, and if you observe, everywhere here reluctance is going to be same, right? everywhere here reluctance is going to be the same, because this is also a circle and this is also in the same form of a circle. So here if you see reluctance here, reluctance here, reluctance here, reluctance here is going to be the same. That is the reason here if you see the distribution will be, so here if you see, since the reluctance everywhere is same, flux is going to be like this only. Let me say that it is like this, constant, right? Now let me come here, see what is going to happen. In case of south pole, if you see, since it is exactly opposite to the north pole, since the flux lines here are outgoing, here they are incoming, since it is exactly opposite, what I am going to do, I am going to let us draw here like this. Almost it is constant, right? Now here is the main glitch. See here is the thing which we should understand. See, this is the point where I was saying here where flux is going to be the zero. How it is zero, let us see. Now if you observe, the flux will come out like this here. The flux will go in here like this. Flux will come out here like this. Flux will go in here like this. Right? Now if you observe here, what is happening? Here if you see, the reluctance is same. Why? Because the length is same. Here if you see, reluctance is going to increase. Why? Because length of the flux path is going to increase. What is length of flux path, sir? Come here, come on, see. See, the formula for reluctance is 1 upon mu length of flux path upon area of the core, cross section of the core. This is the formula. Now if you see here, everywhere if you see, the length between the rotor and my stator is same. Here if you see. So, and area of cross section we are considering constant. Mu which is there, it is basically a constant only. Constant minus permeability, we know that. Now say here, this is L pi. L pi means what? It is going to be length of the flux path. If you see here, length of the flux path is same. That is the reason reluctance is same. Reluctance is same means what? Flux is going to be the same. How? Because flux phi is nothing but mmf upon reluctance. This is flux. Flux phi is nothing but mmf upon reluctance, right? So if reluctance is constant, which means flux is going to be constant here. Similar way here also flux is going to be constant. Now here is the thing. See, I was saying that at this position flux is going to be the zero. Let us see. Here flux is going to be the zero. How it is zero? Let me tell you. See here, if you see, as I move out of this pole like this, as I move from here to here, the length between this stator and my rotor is going to increase. Length of the flux path between the stator and my rotor is going to increase as I am moving like this. Agreed? The moment this length is going to increase, what is going to happen? Reluctance is also going to increase. The moment reluctance is going to increase, what will happen? Reluctance is increasing here, which means flux is going to reduce. Denominator is increasing, whole number is going to reduce. Right? See here, when I talk about 1 by 2 and 1 by 4, who is greater? 1 by 2 is greater, right? Now, see, which means what is going to happen? Flux is going to reduce here like this. And finally here it will become zero. Why it is becoming zero? Let us understand. If you see here, at this particular point, if you see at this point, the effect of North Pole and effect of South Pole is exactly similar. And we know that North Pole and South Pole are exactly opposite to each other. And here if you see at this point, the effect from the North Pole and the effect from the South Pole is same. And the effect is opposite. See here. Flux line from the north is here like this, coming like this. Flux lines from the south is going like this. Which means if you see here, at this particular point, effect of north pole and effect of south pole is going to be the same, and since the effect is opposite, here flux is going to be the 0. Reason number 1. Another thing is, because the length is increasing, so tremendously reluctance will increase. Reluctance is increasing means what? Flux is going to reduce. So here I will get 0 flux. Then again this moves here like this, and this and this. I hope now you have understood. Now whatever this axis I have shown is nothing but space. Now let me tell you here one more thing. See, observe carefully. This particular axis where my flux is going to be the 0, is called as geometric neutral axis. This is called as geometric neutral axis. And since here if you see the flux is also 0, it is also called as magnetic neutral axis. Magnetic neutral axis. Why? Because if you see magnetic property is flux. Here at this axis flux is 0. That is the reason it is that way. Anyways, see here. Coming back to our point. Is it proof that why here if you see flux is 0, why here flux is 0, why here flux is positive maximum, here flux is negative maximum? We have understood it from the figure. Now, see here, space displacement means what? Stop the time, right? We have stopped the time. The moment I stop the time here, anywhere if you stop, it is going to be the same thing only. Now, the moment here time is stopped, what is happening? I am going to move through this air gap. The moment I am moving through this air gap, what will I find? Here I will find more flux, here I will find 0 flux, here I will find negative maximum flux, here I will find 0 flux, which means flux is space displaced. So, conclusion, see here. Now, here if you see, compare both. Yeah. See here. Flux is time displaced, flux is not space displaced in case of transformer. In case of DC machine, what is happening? Flux is not time displaced, but flux is space displaced. What is this meaning? If you combine both, you will understand that flux or MMF or flux density can be either time displaced or space displaced. So, conclusion number 2. Here if we see flux or MMF, or what do we say? Flux density can be both time and space displaced. Means flux MMF or flux density can be time displaced also, and it can be flux displaced also. This is what we have understood. So, in turn, what were the observations? Number 1, currents and voltages are time displaced always, whereas flux MMF, flux density can be either time displaced or space displaced. Thank you.